What's up, guys? This is LeetCoder. This is LeetCode 141 linked list cycle. Essentially, we're given a linked list and we want to return if the linked list has a cycle. And it has a cycle if the last element points to a previous element. Okay, we have our linked list here, 1, 2, 3, and the 3 points back to the 2. Therefore, this linked list has a cycle and we would return true. Now, if we didn't have this arrow here pointing back, we would return false. Now, we can't really brute force this because you'll notice that if you go from this element to the next element, to the next element, to the next element, it keeps going forever. Therefore, we need to keep track of which elements we've seen. So we're going to have another data structure here, and we'll call it seen. And we'll go to the first element. We haven't seen it already, so we add it to our set. Okay. Then we go to the second element here. We haven't seen it already, so we add it to our set. Okay, and then we go to our third element. We haven't seen it already, so we add it to our set. And then we go to our second element again because of this loop. And oh, we have seen it already, therefore we return true. Now in the case where this was not a loop, then we would simply get to the very end of the linked list and we would return false. In terms of time complexity, this is O of n because we're going through each element once. In terms of space complexity, this is O of n because we're storing a data structure with n elements. Now, how can we improve this? Well, we can actually come up with an algorithm that has O of 1 space complexity. And so let's get rid of our data structure here. We don't need it. So what if instead of having just one pointer, we have 2 pointers? So we have 1 here, and then we have 2 here. And the first pointer is going to go through 1 by 1. And the second pointer is going to go through 2 by 2. So let's run through this now. So the first iteration, we move the first pointer up by 1, move the second pointer up by 2. Okay, second iteration, move the first pointer up by 1, and the second pointer up by 2. So you'll notice it goes here and then back here. And in this case, the 2 pointers meet, and therefore we return true. Now, when there is no loop, eventually the pointers will reach the end of the list and will just return false. And this way we can actually avoid any extra space complexity. So this is called the tortoise and the hare algorithm. And no matter the size of the linked list, as long as there is a loop, the 2 pointers will eventually meet. And this is mathematically proven, and you can look that up on Wikipedia if you're interested in the proof. And those are the 2 algorithms that work for this problem. So before we get to the code, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. With that said, let's get to the code. Okay, let's do our first solution. We're going to have our set here, and we're going to have an iterator. And while the iterator is still there, it's not none, then we check if iterator is in scene. If it is, we've seen it, and we can return true immediately. Otherwise, we add iterator to the set, and we then iterate. And then if we reach the end of the list, we can just return false. Let's run that code. Let's submit that. Okay, got the right answer there. And now let's implement the second solution. So this one's a little trickier. We're going to have 2 pointers now, slow and fast. And what we're going to do is we're going to check while slow.next and fast.next and fast.next.next, right? Because we want to iterate slow by 1, we want to iterate fast by 2. So we need this, and we need this fast.next here just to make sure that fast.next isn't none, so we don't call next on none. Now we have that. Now we have to iterate slow and fast because we can't check right away because we know that they're both equal to head in the beginning. Now we iterate slow, we iterate fast, and now we can check if fast equals slow, then we return true. And then at the very end, we return false. Now there's one other case you have to think about, and that's if the list is empty, because then we'll be calling next on none, and that's not allowed, right? So we need to do if not head, then we return false immediately. And let's run the code. Let's submit here. And that's it. So in terms of how to think of this algorithm, it's very difficult the first time because it's kind of a paradigm shift in how you think about these kind of algorithms. But once you see it for the first time, you'll kind of add it to your toolbox of algorithms and you'll have it for foreseeable future. And in fact, a lot of linked list problems have some kind of trick with them where there are 2 pointers instead of just 1. And once you kind of keep that in mind and you see a linked list problem, just think about having 2 pointers instead of 1 and seeing if that makes the algorithm any better. Personally, I prefer the other algorithm with the set because it's so much more obvious and so much more readable. And I don't think the space complexity is that much more. I mean, if we look at our submission here, the memory was only 1 megabyte more. And that's it. So let me know down in the comments if there's any problem you'd like to see next. And make sure to hit that like and subscribe button. See you next time.